Hey guys, today we are learning integration by parts. So if you're learning integration by parts, this means you already know normal integration. What is integration? It is the opposite of derivatives. So you use antiderivatives to find the integral of a given function. For example, we have the integral of 2x dx is going to be equal to x squared. We have a list of antiderivatives that you should memorize or have on your cheat sheet if you're still a beginner with antiderivatives. Now, if we have an integral like x ln x dx, we have no you could memorize the antiderivative for x ln x, but we have no special way to know what is the integral of x ln x, because it's a product of two functions. And none of these functions is a derivative of the other. In this case, we use integration by parts, which is a very simple concept if you learn it correctly. So first thing, we're going to choose one of the functions, the easiest one to integrate or the easiest antiderivative to find. So for ln x, if I ask you what's the antiderivative of ln x, it's going to be a very long one, a very hard one, very challenging to remember. But for x, the antiderivative of x is very common and easy to remember. So what we're going to do is say x, and what's the antiderivative of x? It is x squared over 2. Next, we're going to take ln x, and this time, instead of taking the antiderivative, we're going to take the derivative. What's the derivative of ln x? It's 1 over x. Now, next step is very simple. What we're going to do is multiply these two. So the integral of x ln x dx is equal to multiplying these two, x squared over 2 ln x, minus the integral of the multiplication or the product of these two, minus the integral of x squared over 2 times 1 over x dx. So this one's going to stay the same. And then this one is going to become the integral of x over 2 dx. So with integrals, we could always take the constant out of the integral. And then we know the antiderivative of x is x squared over 2. So this is going to give us 1 over 2 x squared over 2. And then at the end, that's all. At the end of the integral, since this one isn't a definite integral, we're going to add plus the constant c. This is a simple example of integration by parts. So what the rule is, I give you an easy way to find the solution, but the rule is we took ln x, which is the same function here, let's call that u, and then x we multiplied by the antiderivative of x, so let's call that v. The antiderivative of x, so x is the derivative of this, so that's dv. So dv, the integral of dv du, and let's write it u dv better, is gonna be both. This one is the function, and this one is the function, the derivative, the derivative. So these are derivatives, and these are functions. So both the functions multiplied by each other, which are u and v, minus the integral of this function multiplied by this derivative, which is v du. So u dv is equal to uv minus v du. So you're actually gonna inverse these two. So what was the function is gonna become the derivative. What was the derivative is gonna become the function. But I think that the easiest way to solve a integration by parts problem is using this way. Let's try another example. One of the simplest examples for integration by part is actually integrating ln x dx. So in this case, we have two functions. The first one is going to be ln x, and the other one is going to be 1. So now we got to identify which one is u and which one is dv. U and dv. Or let's put dv on top. So always put dv on top, u down. Okay? So dv is equal to, and it's going to give us a v, and then u is equal to, and it's going to give us a u. Now, which one is easier to find an antiderivative? Obviously, ln x, we're trying to find the antiderivative of ln x, or the integral. So it's impossible to put ln x here. We have 1 times ln x, so we're going to put 1 here, and the antiderivative of 1 is x. So automatically, ln x is going to be u, and what's the antiderivative? What's the derivative of ln x? It's 1 over x. Now we're just going to do the same process here. This one times this one minus the integral of these two. So we're going to get the integral of ln x dx is equal to x ln x minus the integral of x over x dx, which is the integral of 1. The integral of 1 is simply x. And then we add the constant c. The most important part in the integration of by parts is trying to find dv and u, trying to find the best ones. And I like you always to ask the question, which one is easier to find an antiderivative for? And this is integration by parts. It could be harder, it could be easier. These are just simple examples. We could get to more advanced ones. Thanks for watching.